Algebra 2. This is day 1 of recording videos for while we are on break or whatever you want to call this time period, I guess. What I'm going to do is I'm going to record this video for chapter 9 or section 9.1, I guess. And then what I'll try to do is I'll try to embed some questions in the video. For this first section, you're not going to have a whole lot of homework. It's just going to be kind of answering the questions as we go, just to kind of check and see how things are going. So, yay for no homework, but you got to make it through the video. So, I'm going to start by, I'm going to share my screen here with you. You should have your notes for section 9.1 that I sent home with you. If you don't, I can try to post those up on Google Classroom. But 9.1, it's kind of a stapled page. So what I'll do is I'll separate this into 2 separate videos. So it shouldn't be terribly long. I don't know why let me close out my screen and then restart it. Hold on. No, still not one to go. All right, hold on just a second. There we go. All right, so this is what section 9.1 looks like. And one of my kids spilled some water, so I had another page bleed onto this, so that's why that's kind of colored there. But 9.1, so we're starting trig functions. This is just an introduction to trigonometry, so don't think that you're going to be doing all the same stuff as what trig does. But trig, really, like the root word of trig is studying triangles. So that's kind of what we're analyzing here, and more specifically, we're going to be talking about right triangles. So what I'm about to teach to you will only work if we have a right triangle. Only for right triangles. Okay. So that's all we're going to be dealing with in this section, and probably in most of the sections of this chapter. This is quite a big box of information here. But what they're referring to is this triangle over here to the right side, and then they have the sides labeled. This is angle theta, and theta is a symbol that kind of looks like this if you write it out. It's like a circle with like a squiggly kind of line through it, okay, or a circle with a line through it. And it is pronounced theta. And theta is just another variable. It's like X or Y or Z or any of those, but a lot of times they'll use theta to represent angles. So they have theta down here in this corner just to kind of know that, like, hey, we're talking about this guy, not talking about this angle up here. We're talking about this angle, okay? And then we have the sides labeled. This is a length of 3, this is a length of 4, and this is a length of 5, okay? He has a special right triangle, 3, 4, 5. You guys might know this already, but triangles that are right triangles have to follow the Pythagorean theorem. So that's a squared plus b squared equals c squared. And a in this case could be 3 or 4, but if I take those guys and square them, 3 squared is 9, 4 squared is 16, that adds up to be 25, so that checks out, okay? So this is a 3, 4, 5 triangle, and what they're doing is they're having us write out the relationships of the sides to one another, okay? Some of you guys might have heard of the term SOHCAHTOA before, okay? And that's going to be a huge thing to remember in this section. So write this out, S-O-H, okay? Make the S a big S and the O-H, make them kind of smaller, C-A-H and T-O-A, okay? So SOHCAHTOA. Okay, the S, the C, and the T stand for sine. It's the full word is S-I-N-E, but they abbreviate it as S-I-N. Okay, do not pronounce it as sin. It is still pronounced sign, like almost kind of like S-I-G-N, like a road sign. Okay, the C stands for cosine, not cos, even though it's abbreviated as cos. Okay, but it's called cosine, and then T is tangent. Okay. Don't pronounce it tan. It's still called tangent, even though we shorten it to T-A-N. Okay, and then we'll talk here in just a second about what these guys mean. Okay, but we have sine, cosine, and tangent. Those are the 3 main trig functions that we're going to talk about. Okay, And SOHCAHTOA is going to help us figure out what each one is. You guys hear my kid yelling, "Mommy, Mommy, come in the other room." Okay, whatever. Hold on. So S has an O and an H after it. Okay, that means that sine, when you're doing the sine function, has the relationship of opposite over hypotenuse. So if we're talking about this guy as being my angle, okay, I'm talking about the side that is opposite him. Okay, the side that's opposite is going to be 4. The side that is the hypotenuse is the longest side, which is 5. And then the other third side is going to be called the adjacent. So we have opposite, hypotenuse, adjacent. Okay, so all that we do is when we're writing out sine of theta, we're doing opposite over hypotenuse, 4 over 5. And this is how we will write out sine of theta. Okay, cosine of theta is A and H, so it's the adjacent side over the hypotenuse side. Okay, so that would be, in this case, 3 over 5, adjacent over hypotenuse, 3 over 5. That's what cosine will look like. Okay, and then tangent is opposite adjacent. So I have the opposite side over the adjacent side, 4 over 3, and that's what he will look like. Okay, and then we'll get to these 3 down here and kind of what they're talking about. But all we're doing is talking about sine, cosine, and tangent. We're talking about sides in relationship to each other. Okay, so once we've identified the angle, the one opposite him is labeled as an O. The hypotenuse is the longest one always, and the adjacent side is the one right next to him. So adjacent means right next to. All right, so if we go down to example 1, here we go. We've got 8, 15, 17. That's another special right triangle. If you put him into a squared plus b squared equals c squared, he comes out really nice. So here's the angle that we're talking about. We're not talking about this angle up here. We're not talking about the 90-degree angle. We're talking about this angle. Okay, so let's go ahead and just label these things. Okay, so think about which side would be the opposite side. Okay, the opposite one is going to be the one right here. I'm going to label him with an O. Okay, the hypotenuse is 17. The adjacent is the one right next to him, which is 15. Okay, now some people think that 17 is the adjacent side because 17 is also right next to my angle, right? Like it's right next to him. But because he's the longest side, like the hypotenuse one kind of trumps the adjacent side, okay? So he kind of has 2 adjacent sides if you want to think about it that way, but the hypotenuse side is gonna take precedence, and he's gonna be labeled with an H, okay? So sine, we go off of SOHCAHTOA. So sine is opposite hypotenuse, okay? So I'm gonna have my fraction here. The opposite side is 8. The hypotenuse side is gonna be 17, okay? All right, cosine is CAH. So that means I do adjacent as my top number. The adjacent side is 15. The hypotenuse side is 17. So that guy is 15 over 17. Okay, and you're just writing these as fractions. You're writing the sides in relationship to each other. And then tangent, the last one, is OA. Tangent is opposite over adjacent. The opposite side is 8. The adjacent side is 15. Okay, and that's just how I write those fractions, just like that. Okay, all right, so now the other 3, they want us to find the 6 trig functions. These are the main 3. I'm going to put main 3 functions. Okay, but then they have these guys that go with them, okay, and these are called reciprocal functions, okay, and the way that reciprocal functions work is they're kind of the opposite of their significant other. So like sine and cosecant are like husband and wife, they kind of go together, okay? So CSC is the full word spelled out is cosecant up here at the top, okay, cosecant. SEC is secant, and then COT is cotangent. Cotangent is easy to remember because it's tangent and cotangent, they kind of go together. But then I have a lot of people that get confused. They think secant goes with sine because the S and the S would go together, right? That would just make sense, right? And then cosine would go with cosecant, but that is not the case. They actually go with the opposite one, right? Okay, so sine and secant don't go together. It's C and S that go together, and C and S that go together, okay? And then cotangent and tangent, that's when it's easy to remember. But the co doesn't go with the co. The sine doesn't go with the secant. Sine goes with cosecant, okay? And so when we're trying to do these trig functions, this is the very easy part. Cosecant will just be the opposite of what sine is, right? So instead of it being opposite over hypotenuse, it's going to be hypotenuse over opposite. Or I can just take these two and flip them around. So it would be 17 over 8. Okay? Secant will be 17 over 15. And cotangent will be 15 over 8. Okay? And that's just kind of how those husband and wife will work together. They're called reciprocals. They're like the flip of each other. Okay? So cosecant is 1 over sine, or it's kind of like taking sine and flipping it around. Secant is 1 over cosine, and then cotangent is 1 over tangent. It's like flipping those guys around. Okay? All right, so let's go to the second page. We'll see how much more of this we're going to do. And yeah, let's do this one. Okay? So in this case, it says sine of b, okay, is 5 over 8. I'm going to write SOHCAHTOA up here. Okay, so H, C-A-H, T-O-A. Okay, that's a good idea to write down anytime you're doing a problem like this. Just write it out until you have it memorized, okay? Now, the important part here is sine of B. We're talking about angle B. We're not talking about angle A. We're not talking about angle C. We're talking about B. And it says sine of B is 5 over 8. That means the opposite side is 5 and the hypotenuse side is 8, since sine is O and then H. It's S-O-H. Okay, so I'm going to label which side is opposite of side B. Okay, it is CA. So we're going to label that as 5. Okay, the one that's opposite, or the hypotenuse side, is going to be 8. So we have that going on. All right, and then we have to figure out what this third side is, okay? And I've kind of given you a hint already as to how we find that. What we're going to do is we're going to do the Pythagorean theorem, okay? So a squared plus b squared equals c squared, okay? Now, it's really important to make sure you find c probably first, because c has to be the longest side, okay? So your hypotenuse is going to be your longest side always, and that's going to be what c is, 8. So I'm going to put 8 squared in that spot, okay? Then it really doesn't matter what a and b are. I could switch those two around, so let's call our question mark a, and maybe 5 will be b. Okay, so I'm going to label this as a. We're going to leave him a, and we're going to put 5 in for b, and then we'll solve what this one is, okay? So a squared is just going to stay a squared, but 5 squared is 25, and 8 squared is 64. Okay, and then from there we just solve for a, all right? So to get a by itself, let's subtract 25. And a squared is going to be 64 minus 25 is like 39, I think. Yeah, 39, okay? And then a, if I take the square root, will be the square root of 39. Okay, and I don't think, I'm trying to think, the square root of 39, does that come out nicely? Well, it's not a perfect square, but like, will it break down is what I'm saying. I don't think it will. 3 and 13 maybe, but those aren't perfect square roots. So we're just going to leave him as the square root of 39 for now. Square root 39, okay? All right, so now I just need to write out what sine, cosine, and tangent are for each one. So I'm going to make these guys into fractions here, fraction here, fraction here. Okay, so sine of b. We want sine is opposite hypotenuse. The opposite side is, well, let's just label them. Here's b. Opposite of b is going to be 5. Hypotenuse is 8. And the adjacent side is the square root of 13. Okay, don't put him as a decimal. Just leave him as the square root of 13. And we'll just deal with him that way. Okay, so sine of b is opposite over hypotenuse. Opposite's going to be 5. Hypotenuse is going to be 8. Okay, then let's move on to cosine. Cosine is adjacent over hypotenuse. The adjacent side is the square root of 39. I should have written smaller, sorry. Square root of 39 over the hypotenuse side, which is 8. And then tangent, the last one, is opposite over adjacent. Opposite is 5. Adjacent side is the square root of 39. Okay, that's what he will look like. All right. Now, let's see, Tori and Lacey. I don't think I'm going to have you guys worry about rationalizing this thing, so you don't have to multiply by the square root of 39. We'll get to that when we do more in-depth trig stuff. Okay, So just leave him as 5 over the square root of 9. I'm going to say that that's going to be fine for now. Okay. Now cosecant is like the husband to sine, and we're going to flip him to make him cosecant. So he would be 8 over 5 instead of 5 over 8. Secant will be 8 over the square root of 39. And then cotangent will be the square root of 39 over 5. Okay, and I think that's as far as I'm going to go with this video. We'll continue the rest of it in my next following video. Right now, this doesn't make a whole lot of sense, like why we're doing this, because we're not really solving for anything. But eventually, we'll get to the point where, given this information, I can find out exactly how large B is. So maybe B is 30 degrees. Maybe B is 47 degrees. We don't know. We don't know this yet, but we'll get it to a point where we can actually find out how large that angle is based upon how the sides are. Okay, so that's kind of what we're leading up to into. This stuff that we're doing right now shows up on the ACT like crazy, which I know I shouldn't say that because like the ACT, the juniors probably aren't even going to take that this year. But it shows up on standardized testing a lot. This is like the main trig stuff that is really important. So we'll continue the last bit in my next video. Okay.